Jai Hind. Myself Nidhi Singh, Assistant Professor in Electrical and Electronics Engineering Department. So today I am going to discuss the question paper of session 23-24 of semester 2nd, and the subject is Fundamentals of Electrical Engineering. So let's start. So we know that AKTU paper, in AKTU paper we have three sections, section A, B and C. So in section A, each question carries 2 marks. So the question 1A is, what is unilateral and bilateral element? So unilateral element, these elements allow current to flow in only one direction and their behavior changes if the direction of current is reversed. Like for example, diodes and transistors. A diode conduct current in forward direction but blocks in reverse direction. We know very well. So if we have a diode, excuse me. So if we have diode, if this is your diode, so current can flow only in one direction. For one direction it will be forward and for other direction it will be in reverse bias, right? For one it is forward bias and for other it is reverse bias. So current will only flow in one direction, and if the direction is changed, its behavior also change. Its behavior is changed means in another direction it will behave in a reverse bias. Now the next, what are the bilateral element? So these elements allow current to flow equally in both directions. Their behavior remains the same regardless of the current direction. Like for example, resistor or inductor. So resistor offer the same resistance whether the current flow in from one end to other or in the reverse direction. Like for example, if this is a resistance, this is point A and this is point B. If current is flowing from A to B, its behavior will be same, and if current is flowing from B to A, its behavior will be same. So there is no change in the behavior by changing the direction of the current. So such kinds of elements are called bilateral element. The next, next is, what is Kirchhoff's law? So Kirchhoff's law, there are two laws. One is KCL, which is called as Kirchhoff's current law, and other is KVL, which is called Kirchhoff's voltage law. So first we will see what is KCL, that is Kirchhoff's current law, right? So Kirchhoff's current law is the total current flowing towards the junction point is equal to the total current flowing away from the from that junction point, right? Or like this is your junction point. So the incoming current is I1 and I2. So from this we can write that I1 plus I2, this is equal to outgoing current, which is I3 and I4. Or in other way, we can also define this KCL as the algebraic sum of all current meeting at a junction point is always 0. So sum of all these current will be 0 at a particular junction point. So of course, we will take a sign convention here. So current flowing towards the junction point are assumed to be positive, while current flowing away from the junction point can be assumed to be a negative. So if we write according to this, so we can write I1 plus I2, so minus I3 minus I4, this is equal to 0. So sum of all the algebraic sum of all the current at a junction point is equal to 0, or you can say that total current flowing towards the junction point is equal to the total current flowing away from the junction point. So this is your KCL, right? Now what is KVL? So KVL is, in any network, the algebraic sum of the voltage drops across a circuit element of any closed path is equal to algebraic sum of the EMFs in the path. Or in other word, we can say the algebraic sum of all the branch voltage around any closed path or closed loop is always 0. So summation of voltage will be equal to 0. Suppose if we take this circuit, here we have voltage. This is your V1, here we have R1, R2, and this is V1. So we can say that this V1 minus, if current is flowing here, is I1 R1 minus I2 R2. So this will be equal to 0, right? So this is your KVL, which is Kirchhoff's voltage law. Now the coming to part C. So part C is, what is the average power in pure capacitive circuit? So average power in a pure capacitive circuit is equal to 0, as the average power we know is Vi cos phi, right? And we know that in capacitive circuit there is a phase difference of 90 degree between V and I, and the current leads in the capacitive circuit and voltage lag in capacitive circuit. This voltage lag with this current by 90 degree. So cos phi will be here is equal to 0. So cos phi will be 0, so average power will be equal to 0. And the question can also be, what is the average power in pure inductive circuit? So answer is same. In pure inductive circuit also the average power is equal to 0. Now the next is, what is the condition for positive voltage regulation in a transformer? So the condition for positive voltage regulation in a transformer, that the load should be inductive, or nature of power factor is the nature or the power factor that should be lagging power factor, right? So or the same question can become as, what is the condition for negative voltage regulation in a transformer? So in case of negative voltage regulation, the load should be capacitive in nature, or we can say that there should be a leading power factor, right? So the question can come in both way, the condition for positive voltage regulation or the condition for negative voltage regulation. So for positive voltage regulation, the load should be inductive or lagging power factor, and for negative voltage regulation, the nature of load should be capacitive and a leading power factor. Now write the formula for efficiency of transformer, and what is the condition for maximum efficiency of transformer? So the formula for efficiency of transformer is like for efficiency at the nth x load, we can say the is x V2 I2 cos phi 2 or x V2 I2 cos phi 2 plus iron loss plus x square copper loss, and this copper loss is your full load copper loss, right? And the same can be written as x VA rating by this V2 I2 cos phi 2 is nothing but a VA rating, x VA rating plus iron loss plus x square copper loss at full load, right? Now the condition for maximum efficiency is when the iron loss and copper loss are equal. When both the losses are equal, we get the max efficiency. So the load which should be at max efficiency, this x is equal to under root iron loss by copper loss at full load. So Pi by PCU means copper full load copper loss of transformer, and Pi is iron loss of transformer. Then next is a 3-phase 440 volt 50 Hz induction motor has a 5% slip. What will be the frequency of the rotor current? So here we have a 3-phase 440 volt 50 Hz induction motor which has a slip of 5%. So what is the frequency of a rotor current? So we know that the relation is Fr is equal to S into F, right? So here the slip is given 5%, so this will be equal to 0.05, and the frequency is given 50, right? So you will get 2.5 hertz. So Fr is SF 0.05 into 50, you will get 2.5 hertz. So this is how you will solve this numerical, right? Then the next is, what are the common problems that occur during electrical installation? So the common problem that occurred during the electrical installation, the same question came in the odd semester also in 23-24. In odd semester also you can find this the same question. So the first is improper wiring and loose connections. So loose or improperly connected wires can lead to sparks, overheating and fire hazards. Like for example, loose neutral connections can cause voltage fluctuations. Then the second problem could be overloaded circuits. Connecting too many devices to a single circuit can cause overheating and circuit breaker trips. Like for example, using multiple high power appliances, like for example heaters, air conditioners on the same circuit. Then the other point, it could be incorrect wire sizing. So using wire with inadequate thickness can cause excessive resistance and heating. So like for example, using a small gauge wire for a high current appliances leading to potential fire hazards. Now the next is faulty grounding. So faulty grounding, missing or improper grounding increases the risk of electric shock and equipment damage. Like for example, not connecting ground wires in outlets and electrical panels. So these could be a common problem that occurs during the electrical installation. As this is a 2 marks question, so 4 points are enough for the answer. Then the next is this is the question from section B. So section B, the first question is using nodal analysis, find the branch current in the circuit. So you have to find the branch current in the circuit. So here you can see the circuit. So you have to solve this question by using nodal analysis. So first we will assume the here we can see that we have 1, 2 and the reference node is here, right? One second. Okay. So here we will assume V1 voltage, here we will assume V2 potential. So here we can see that potential at V1, this is equal to 6 volt, as in this branch no resistance is there. So here V1 is at 6 volt potential. So we can write V1 is equal to 6 volt, right? So we only need to write equation for this node V2. So here we can write, so now assuming V2 as a at higher potential, so we will write V2 minus V1 by 2 for this branch. Now for this branch we will write V2 by 12 as this reference is at 0 potential. Then this 4 ampere is entering in this node, right? So we have written outgoing current as a positive. So the incoming current we will write it with negative sign. So this is equal to 0. So here we can solve this equation V2 minus V1. We know that V1 is 6 by 2 plus V2 by 12 minus 4 is equal to 0, or you can write V2 minus 6 by 2 plus V2 by 12 is equal to 4, and after solving this you can find value of V2. So value of V2. So here you will get value of V2 is 12 volt. So in this question you have to find current in all the branches. So in all the branches, like if you have to find current in this 2 ohm, so the current in 2 ohm will be equal to V2 minus V1 by 2. This will the value of current in 2 ohm. So V2 value is 12. V1 value is 6 divided by 2. So here you will get the value of current in 2 ohm, right? Similarly, if you want to find the value of current in 12 ohm, so this will be V2 by 12. So V2 by 12, the value of V2 is 12 by 12. So current in 3 ohm, this will be equal to 1 ampere. So, this is how you can find current in all the branches. So, you can see that you are getting 3 ampere, 2 ampere, 1 ampere and 4 ampere in all the branches. So, this is all for today. The next remaining questions we will discuss in the next lecture. Thank you.